Hello, welcome back to Shareability Uganda. Still on our topic, matter and energy. In this lesson video, we shall be looking at magnetism. Magnetism is a force in a magnet that has the ability to pull or push magnetic substances. Remember, magnetic substances are substances that can be attracted on a magnet, or are substances that can be pulled or pushed by a magnet. Substances that can be affected by magnetic forces are called magnetic substances. A magnet is a piece of metal with the ability to attract magnetic substances, or is a piece of metal that has or produces magnetic force is a magnet. A magnet is made up of two poles, named the North Pole and the South Pole, as you can see in the video. Magnetic substances are materials which are attracted by a magnet, and they include iron, steel, lead, cobalt, among others. However, non-magnetic materials or non-magnetic substances are substances that are not affected by magnetic forces, and they include rubber, plastic, paper, cloth, wood, and etc. However, magnets have various properties, which include 1. When a freely suspended magnet faces in the North Pole, when freely suspended, a magnet rests in the north-south direction. When freely suspended on a string, the magnet will rest in a north-south direction, as illustrated. And then another property of magnets is that magnets are strongest at the poles. We'd find that magnets have two poles, the south and the north pole. Magnets are strongest at these poles, at the south and the north pole. Remember, unlike poles attract and then like poles repel. For example, as in the diagram, north will attract south pole, but north and north will repel, and also south and south poles will repel each other. And another property of magnets is that magnetic lines of force run from the north to the south pole, as illustrated. They run from the north to the south pole, the magnetic lines of force. Another property is that when a magnet is broken in two pieces, each piece becomes an independent magnet with a north and south pole, as illustrated. We have various types of magnets. We have natural magnets and artificial magnets. Natural magnets are magnets that exist on their own in nature without man making, and they include lodestone and the earth. The earth itself is also a magnet because it has its own magnetic field. And then we have artificial magnets, which are magnets made by man, and they include horseshoe magnets, bar magnets, cylindrical magnets, needle magnets, and electromagnets. Types of artificial magnets we have temporary magnets, which are magnets which lose their magnetism easily, e.g. the electromagnet, the one that is used in electric bells. And then permanent magnets are ones that retain their magnetism for a long period of time. Examples include a horseshoe magnet, a bar magnet, cylindrical magnets, and needle magnets. In the picture is an illustration of a horseshoe magnet, how it looks like. It's called a horseshoe magnet because it looks like a horseshoe. As you see on the right is a picture of a horseshoe, and then on the left is a picture of a horseshoe magnet. And then we have a bar magnet. As you can see, it is in a bar form, like a bar of soap. Then we have a cylindrical magnet in a cylinder form or cylindrical shape. We have a needle magnet, ones that are used in compass directions. They look like needles, sharp and pointed. Terms used in magnetism: we have poles of magnets. These are the ends of a magnet, the one we call the north and south pole. And remember, we said magnetic lines of force run from the north to the south pole. And then we have what we call the magnetic field. A magnetic field is an area around a magnet where the force of magnetism is forced or experienced. Then we have magnetic lines of force. These are lines around the magnet through which magnetism runs from north to south pole, as illustrated in the diagram. Then we have various ways of making magnets artificially. One, we have the stroking method, as illustrated in the diagram. A stroking method, we get a bar magnet and then we stroke it on a piece of steel bar. As illustrated, the end becomes the south pole and the other end becomes the north pole. Then we have another way of making magnets, which is called an induction method. As illustrated, a piece of wire is wound on an iron piece of metal or a nail, and then it is wound in a coil form and then connected to an electrical or power source. The nail this coil, the power going through this coil, the wire that we wound on the nail, will induce a magnetic force into the nail, making our nail a magnet, or any other piece of steel on which the wire is wound becomes the magnet. But that type of magnet will not last long. It will lose its magnetism very quickly. And then the other way of making magnets is the electrical method. It is very similar to that of an induction method. It works in the same property. Ways of destroying magnets. How do we make magnets lose their magnetism or demagnetization? By strong heating. When you get a magnet or any magnetic material and place it on fire or any other source of heat for a long time, it will lose its magnetism. And then also by hammering or hitting. When you hit a magnet strongly, it will lose its magnetism. Then the other thing also is by leaving the magnet in an east-west direction for a very long period of time. Remember, magnets are for them to retain their magnetism for some good time, it is best they rest in the north-south direction. But when they rest in the east-west direction for a very long period of time, they will lose their magnetism. And also leaving magnets in water to rust. When they rust, remember, magnets contain iron, so when they rust, they lose their magnetism. Keeping magnets without iron keepers also makes them lose their magnetism. What are iron keepers? For example, when you want your magnet to retain its magnetism for a very long time, when storing it, you have to get some piece of magnetic materials like nails and then place them on that magnet. When in storage, it will retain its magnetism for some good period of time. The other thing is keeping magnets with similar poles together for a very long period of time. Remember, as we said, similar poles repel. So when magnets are kept with similar poles close to each other, they will be in that constant state of repelling, so they will lose their magnetism. Then passing it through alternating current several times, or alternating current voltage several times, it makes these magnets lose their magnetism. Ways of protecting magnets against the magnetization. We can paint them to prevent them from rusting, keeping them in iron keepers, storing them while facing the north-south direction, storing them with unlike poles together, protecting them against strong heat. Uses of magnets, electricity and magnetism in the modern world. How do we use magnetism or magnets? They are used in compass to show direction. They are used in telegraph and telephone receivers to amplify sounds. Magnets are used in generators to produce electricity. They are used in industries to pick heavy metallic magnetic objects. They are used in electric belts. They are also used in hospitals to remove magnetic materials from the eyes. Ways of increasing the strength of an electromagnet by increasing the voltage, increasing the number of turns on the solenoid. And then advantages of using an electromagnet, its strength can be increased. That is the major advantage of using an electromagnet. Its strength can easily be increased over time. An electromagnet can be demagnetized by passing it through alternating current. Examples of equipments that use electromagnets include an electric bell, sound amplifiers, generators, etc. Uses of electric magnets. They are used in lifting heavy metallic scrap during smelting, like we defined, and also used in electric bells, among others. This is an illustration of how an electric bell works. You can see contacts, the contact screw, part S, then there is part A, then we can see a gong and a hammer, the connecting wires, and the switch, the battery, and the piece of iron core. So when the switch is closed, current flows through the connecting wires and to the piece of soft iron core. When current is flowing, it generates a magnetic force which is induced in the piece of the soft iron. When that force is induced, that soft iron core attracts point A, which has the hammer. Then the hammer hits the gong. When the hammer hits the gong, in that instant, it breaks the circuit at S, and then there's no current flowing. Remember, when there's no current flowing, this iron core loses its magnetism, and that process will repeat. It will repeat procedurally, and that is how the electric bell works. Then lastly, we can look at generating electricity using a dynamo. Remember, a dynamo also uses magnets to produce electricity. A dynamo is an electrical generator which produces electrical energy in form of direct current. It converts mechanical energy to electrical energy and helps in production of electricity when the magnet is made to rotate. Remember, when the magnet rotates, it generates current, and when current is flowing, it generates a magnetic force. So they work simultaneously like that. Dynamos are mostly found on bicycles and vehicles. They are used to produce energy that charges the batteries in vehicles, and in vehicles they are called alternators. This is a dynamo on a bicycle. It is fixed next to a tire, and it has a point that connects to the tire. So when the bicycle is being rode, that tire makes that there's a certain part on that dynamo which is made to rotate, generating electricity, which makes the lamp of that bicycle to light. Thank you for watching this video. Thank you for supporting Shareability Uganda. May God bless you.